Okay, all right. So yes, as David was saying, so 2 months ago, if you guys were here, I did a lightning talk on Streamlit, and then last month I did a lightning talk on Neo4j. So today I'm hoping to conclude this trilogy with a combination of the two and showing you how that works. Okay, so before I really get into it, I posted a bit.ly link into the chat, and let me bring this up in here. Oop. So, and there's a QR code. So what I've done is I've created two Streamlit apps. One is for this mock meetup signup. So if you get a chance, just go in there and you can put in fake name, fake email address, that's fine. But the part where it says, what programming languages it'd be good if you put in, a couple of languages that you do know. And I'll be using the data that you populate in the demo later in my talk. So here. And I will leave that bit.ly link at the bottom throughout my talk, but it's in the chat as well. Okay, so real quick, if you weren't here 2 months ago, Streamlit is a tool, a framework that basically turns your Python script into a UI building app. So what it does is it goes from top down and runs through your script, and anytime it runs across a Streamlit widget, it will render that. And anytime somebody interacts with that widget, it will run that loop again. Okay, and Streamlit comes with a bunch of widgets. So you have a bunch of inputs, a bunch of graphs, all the things that you probably would need for like a really basic web application. Now, again, Streamlit isn't going to be for somebody who's building, really great web pages. This is for people who are kind of more data, more engineering focused, and just want to put something quickly out there to share with other people. Okay, and the last thing is Streamlit is available for cloud and local instance. So the meetup page that I pointed you guys to is hosted on their cloud instance. I really recommend that if you want to get started, because you can just link your GitHub a repo, and it will just go to that repo and pull it and then turn it into a running Streamlit cloud instance. And anytime you push to a particular branch that you set it to look at, it will automatically update. So once you get it set up, you don't even have to putz around with Streamlit. Okay, and I will also be showing a local instance of Streamlit. Okay, so Neo4j real quick. Again, it's a graph database. You can use graph databases for any sort of data store. We're using it for a very basic use case here. But if you have very complex data, very interconnected stuff with lots of different data sources, graph databases are what you should really look into. And Neo4j is an example of a property graph database. So how it's a little bit different is we've got information nodes and a relationship that ties to the nodes. Relationships in all graph databases are first-class citizens. So the data of that relationship is stored with the node data, which is kind of equivalent to like a row data. And what makes a property graph different is that in the node and the relationship, you can store property information. Okay. All right, and other things on Neo4j, they also have a cloud instance, several cloud products, and you can run it locally. And if you don't want to use the managed service, you can, of course, spin up your own service and put it up on Heroku or DigitalOcean. Graph Data Science Package is an add-on that really brings a lot of really advanced capabilities to the graph database. So you can do things like link prediction, community detection, page ranking, that sort of stuff, right in the database. So you can even run a simple ML pipeline in the system. Well, not simple, but you get the idea. And of course, the Python driver, which I will be talking about momentarily. Okay, right into the demo here. Okay, so very non-UML architecture diagram. So whole thing will be written in Python. Streamlit will handle all the UI elements and interactions. And then Neo4j kind of broke up into 2 bits, right? So the database is actually stored in a hosted Neo4j instance. That's the fuel. And then just a simple controller object, which we'll use to instantiate the driver and run it. Okay, in the Streamlit app, I'm just going to demonstrate 3 widgets, 3 of dozens and dozens that they have. Select box for selecting which meetup we want to look at. Metrics widget, which will show some basic information. And then since we're talking graphs, we got a graph visualizer to visualize some graph data. Okay, so actually I'll jump into the IDE from here. On the app that we will be demoing. Okay, so let me switch my camera. Okay, so here we're looking at my Visual Studio Code, hopefully. Okay, So here we're just importing Streamlit, and we have to import the GraphViz package. So Streamlit didn't bake GraphViz into it. It just has a little wrapper that goes with it. So that's imported separately. This constants, I put all the programming languages in here rather than have the client or the server constantly pull this. Since this is not a rapidly changing data set, I just put it as a constants file. And here, Neo4j controller, which we will come to next, here is where the Streamlit stuff starts. So here I've just got Streamlit as ST. So here the title widget is just going to give, a nice little title block of what app we're looking at. Next thing we'll do is instantiate the Neo4j controller with secrets. So this is kind of harks back to what what we were talking to Billy about secrets. So if you use a Streamlit application, you can add a .streamlit folder, and you can put a secrets.toml file in here. And that file is also mirrored in the cloud instance, right? So whatever you put into that secrets.toml, you can put into the cloud instance, which makes using it great. So you can go between the two, and as long as those two secrets configuration files are the same, your apps are talking to the same database or using whatever secrets that you want. Okay, then I'm just asking the Neo4j controller I have to get the meetups and then stick that in the select box so that someone can select one of the meetups. There's just a list of strings. So once they choose it, the meetup _ name gets populated with that string. Okay, so what I will do is, I think I'll just run it from this point, and then we can, then I'll open up for a few questions. Otherwise I'll just be talking about code the whole time. Okay, so to run a Streamlit app locally, once you have it installed, you just do Streamlit run and then your file. And this will automatically open a browser, which you can't see. So let me switch to it. Okay, so this is the meetup dashboard. So we can see this graph is a little tiny here. Okay, so of everyone who had entered data, so I think 8 of us had entered data because I put 1 earlier. There are 16 unique skill sets that had been selected, an average of 6 programming skills per attendee. And here I'm just going to expand the GraphViz, which didn't really help. But we can see here, this is everyone who had entered information attached to this meetup. And here we can see the GraphViz where we have actually quite a bit of overlap, right? Like JavaScript, obviously Python, JavaScript, and then a little bit of C and Java. And what is this? Oh, C#. Cool. Okay, so that is this app. Go back to the Studio Code. Okay. Did anyone have any questions at this point? I mean, I could just stop right here too. Otherwise, I would just go into more details of Streamlit's implementation.
So I'm just curious, for drawing the graph, I know you're using Neo4j. Are you like to store the, I'm guessing you're using Neo4j for storing the data. That's what it appears to be. And then for the graph, oh, you are using GraphViz. Okay, just looking at your code. Awesome. I'm a big fan of different graphing software. So, and GraphViz is an old favorite.
Yeah, yeah.
That's it. Just a comment.
Do you have? Okay, yeah, no, cool. Yeah, it's so I was just using Streamlit's own graph visualizer rather than, I mean, you could use any package really at this point, but because Streamlit has got this, where they have it, yeah, Streamlit GraphViz chart, right? So it neatly puts it into their application. But yeah, I just grabbed basically just graph data from Neo4j and put it in. Oh, that's what I totally forgot. It's to go over the actual Neo4j stuff. So, okay, so in this controller, it's made up of generally 2 components, right? One is these transaction functions. And this isn't the only way you could run query commands to the Neo4j driver. It's just the recommended way because these transaction functions allow the session context manager, which I'll show in a second, to be able to rerun these functions in kind of a stateless form. And these transaction functions, when it's done this way, is also ready to go for cluster scenarios. So if you have a cluster of Neo4j instances, you can just use this and you don't have to like update your code to make it cluster compatible. Okay, so again, transaction function, this is called by And go down to the actual class. So here we've got just a get meetups function. Super simple. It just checks to see if the driver's initialized, creates a context manager for the session, executes a read again with that transaction function. Okay. And the only thing else this controller does is it takes the the URI, the user password, instantiates a driver, gets it ready, allows you to manually close it if you need to. Our case, we don't need to for such a small app. And then you just have all these other functions to call the database. Now, this is kind of, this is what I have here is inefficient. This is really to showcase different Cypher queries to get different pieces of information. Because really the most efficient way would be just to give me the graph data that populated the graph is, and then parse out the data from there. But here I've got individual Cypher commands to, let's see, to get like, give me all the number of attendees by just counting all the attendee nodes. Here, this is where graph gets more interesting, especially using Cypher. So Cypher, again, is kind of an ASCII-like query language. So everything in these parens, is this big enough? Okay. Everything in the parens is a node. Everything in a bracket is a relationship. And you can see here, you can give directions by these dashes and arrows. But here we're looking for, we're starting with the meetup that's named, the meetup that we're looking at based on the select box. And find me all the attendees who attended it and grab all their skills. And then just count all unique instances of those skills and return it as, this key. And then when you get that data back, it's just, number of skills, and it gives that data back. And I think that might be, yeah, so this is the most complex pattern I've got here. But you can see the way that this is set up. You can get into very complex pattern matching using Cypher, especially when you can do multiple matches, optional matches, and more complex like where looks. Here I'm just looking for a meetup, or just for a string. But you could look for things above a certain date, below a certain value, all sorts of stuff just within Cypher, and then have it pump the exact piece of information you want back to you. Okay, I think that covers the Neo4j part. Okay, I think I'm done, David, unless somebody has questions.
Any questions?
Yeah, what size or like what degree of a graph can you load up this way before Streamlit starts to complain, I guess?
Oh, that's a good question. I haven't tried to figure out how far I can go before graph gets unreadable. I would imagine something even just 3 times as much data as what we have put in here already is already going to like be unreadable. Let's see,
I didn't mean GraphViz as much as I meant Streamlit, I guess.
Yeah, no, that's a good question. I don't know. I haven't tried capping it out yet. But that would be semi-easy. So in Neo4j, you can spin up a bunch of preset data sets with like Stack Overflow data or the Panama Papers data. Actually, that's a huge data set. Yeah, I could just spin that up, throw it in, and see if Streamlit can absorb that much.
Can handle it, yeah.
Yeah. Although I don't know if there would be much use giving Streamlit like a ton of data. You're probably better off like, getting fine-tuned piece of information, have Streamlit display that rather than have it handle any large pieces of data.
Right. No, thank you for that.
Yeah.
When I was inputting my credentials into the program, it said that my email was wrong and to try inputting again. But then it also said that it had uploaded all my information.
Yeah. So, okay. So I built both these apps yesterday. Definitely the error handling and validation aren't great. Like I wanted to get it so like if you were putting in, it's such a basic thing, like, putting in information, and then if you had one thing wrong and you hit submit, it wants the Streamlit's default behaviors to wipe out everything in the form. And it's like, just don't wipe everything, just validate one field, keep everything, and then let the user put it back in. But yeah, that okay Streamlit dialogue thing. That yeah, there's not a whole lot it's checking for before it runs. It's just saying like I finished getting to this point in the script, but I haven't actually validated because a little quirk with the way that I'm having Streamlit talk to Neo4j. I gotta modify some code to have it give me an actual like result back that says yes, it was successful. So that's poor implementation on my part, not Streamlit or Neo4j's.
Oh, that's fine. I just noticed when it got rid of all the codes I put in.
Yes, yeah, I was really trying to make it not do that, but I tried a couple different ways to. So the Streamlit form, it's really handy in terms of it gives you a form, but it gives you no way to validate fields.
Oh,
so
it doesn't.
Which it doesn't do that. And the alternate option is to build all the individual components yourself, but the callbacks for the input fields didn't work like I would expect. So I was expecting when one field is completed, I would do this callback and check to see if it was validated, and if things were invalid, it would just display a warning. But no matter what you changed and whatever you sent to that callback, it didn't actually rerun Streamlit. So anyways, that is a peculiarity of Streamlit at the moment, and or my inability to find the right combination of stuff to make this form like a validatable form.
But yeah, it's very cool. Thank you.
Yeah, you're welcome.
Last call for questions before we move to our last speaker.
I have one about Neo4j. Let's say, how is the storage mechanism on links? You have a node, you have, let's say like a person in a family. So I'm looking for the parents. Does it have all of the members of the family, let's see, as having, there's relationships, and does it have to go to each one of the edges and query what type of edge relationship it is? Or is there some, let's say, I guess there's not really this type of edge relationship is stored inside the node for a person. Like this person has two parents and there's a parent relationship. You store that in the node and say, okay, well, it goes this way to these two people or these two other nodes in this graph. I guess you have to go around and query all the edges to find out that relationship.
It depends on your Cypher query, right? So most of the time what will happen is, depending on how your query is written, it'll find some starting node, and then it will traverse that node through the relationship of nodes to complete your request, right? So depending on the query, it'll either do a breadth first or the other one.
Depth first, yeah.
Yeah, breadth first to find all the information you're looking for. And under the hood, like the node data is, I believe, stored separate from the relationship data, but there are links within the file to tell it which index, basically which node to hop to next, right?
Okay.
And then there's a separate file for properties for each node and relationship.
Okay. Good to know. Thanks.
Yeah, you're welcome.
I got one more. Could you just straight up, maybe supply it like an edge list and have it still work? Like if I had, left node relationship, right node in like a CSV, and then just say like import edge list or something.
Oh, so you only want the edges and none of the nodes?
Oh no, yeah. I meant like to construct the graph. If I just had, node 1, node 2, and then the third column is like the relationship, or maybe there's several columns in a CSV. You know what I mean? Like an edge table.
Okay, so the output CSV you want is, so if I'm guessing right, so one column would be node A, and then relationship column, and then the third column would be the node that it's connected to.
Yeah.
Okay. So
not the output, but if that's supplied as the input is what I meant.
Oh, okay. Yes. So if say we were just taking string data and then a string type for the relationship and then string data for the other one. Yes. So you've got actually a couple different ways you could import the data. So from a CSV data, you can, from one CSV file, you could create actually a number of different things. And let me just show you real quickly.
Sorry if we're eating into next speaker. I'm so sorry.
Let's see here.
We have a minute
Okay.
or two. No worries.
So Neo4j just came out with this this tool called Data Importer, which is probably the best way to kind of visualize how to bring data in. Because otherwise, you do have to use a cipher command doing an import, which is fine. But oh, of course, this one's not running. Okay, let me bring it up in Chrome instead, because I know this instance is running because we were just demoing off of it.
Jason, you're kind of far from the mic. It's kind of hard to hear you sometimes.
Hello, hello.
Yeah, you're much better.
Okay. Okay, let me switch to Chrome. Okay, of course, I don't remember my password. Is that it? Nope. Okay. So, oh, wait, I can just grab it from my secrets file. That will work. Not so secrets file. Copy Chrome. Where'd you go? Here we are. Connect. Okay. So, a second to load here. Perspective mode. Restore, sure. Okay, so this is the data importer. So what you can do is you can just grab like CSV files. Let's see if I got any preloaded here. Yeah, companies and people, that sounds good. Boom. Right, so you can see here in this company CSV, it's just got ID and some other info, and people, we've got company ID that we could use as kind of a hook, right? So here, persons, I'm just going to grab all the people CSV and grab their employee ID. Salary, company would just be the company ID. And here at the relationship, I can grab the people CSV that I'd used to populate the person. And here I just want to say, okay, just this works, this new relationship called workset. Just find the employee ID from the that's in the people CSV and find that record's company ID. And then, so just that information from the CSV will be used to create this relationship. And then the same for like reports too, right? So in here, in the CSV, we've got a, well, you can't see my cursor. On the left, there's a reports to column, which just has the ID number, has the employee ID of who that person reports to. So for this relationship, I'm just taking again the people CSV and grabbing the employee ID and the reports. So you can see where even one CSV file, you can cut it up in a lot of different ways to create your data model and import that data right into a Neo4j instance. Hope that helps. I could talk for hours just on this.
Well, thank you very much. That's really great, Jason. The data importer looks pretty useful if you have like a lot of CSVs or something that you can export to a CSV.
Yeah, I totally recommend it. It's because it's also great for just visualizing, like, you know, what is my data going to look like? Like, you know, once you get really into this gets, you know, can get quite complex, but it's a great way of seeing how all the data is interconnected.